Thank you very much for the introduction, and thank you for being here. I'm happy to present our work, our paper, Measuring Readiness to Hand through Differences in Attention to the Task versus Attention to the Tool. This work has been carried on at the University of Waterloo and University of St. Andrews with my co-supervisors, Mark Hancock and Miguel Nacenta. So to start, manipulating physical tool is a common part of our daily activity. And with the best tools that we use in our daily life, we don't even really notice them as we perform our task. For example, we can use a physical pen to interact on a physical paper, and we don't even think, as we use that pen, we don't even think about the pen, we just focus on the task. And we got to this point after a lot of practice and a lot of experience where we get to learn how to use the pen and interact with it to perform our task. And we kind of like hold the pen in our hand really naturally and intuitively. So this kind of a physical interaction is really an important part of our cognitive development. However, our modern world nowadays have been invaded with different types of tools. We might integrate or even substitute physical reality with some of these tools when as we learned to interact with them with the digital ones. Now it would be good if we can feel as confident and interact really naturally with these tools. Some people might call it being embodied with these tools. So we need to find a way to build these digital tools and take advantage of how we interact in the physical world. So we need to find a really good measure in order to measure that interaction. But how we can measure tool embodiment, how we can measure the idea of embodiment. In past work, people have been trying to measure naturalness and other characteristics of the tool use, but they mostly do it in a more indirect and subjective way. Some people might be tempted to just measure performance or speed, but it doesn't quite capture the notion of being embodied with a tool. Alternatively, we can ask also people, like asking them with questionnaires, but this measure are often unreliable and really hard to quantify. So what we can do about it? This is where we come in. So if there is a main message that I would like you to take from this talk, this will be it. We constructed a framework which can be used to directly measure embodiment by comparing attention to the task versus attention to the tool. And we started thinking about how we can understand how we interact in the physical world, how we can understand how we interact with tools in the physical world. One of the philosophical ideas that stood out at the time is that this idea that Heidegger introduced, readiness to hand, and it later was discussed by Dorish and Winograd in a more of an HCI context. Readiness to hand describes how we interact with the tool and we forget about it, essentially. And we also looked and tried to make the link how our attention is changed and affected when we are in a state of readiness to hand. So a famous example that Heidegger introduced with the readiness to hand is using a hammer. When we use the hammer skillfully in order to hammer a nail, we focus on the task and we forget about the tool. So essentially the tool becomes invisible. We don't see it. We only start seeing it if the tool gets broken, or we don't have really the skills to use that tool. And how this links to attention, as we use the tool and we forget about it, we pay more attention into kind of the tip of the tool and the task that we are performing with that tool, and we pay less attention to the tool itself. So we took those ideas, we took those philosophical ideas, and we took attention to it and built our model. So Heidegger introduced 3 stages of interacting with a tool. Readiness to hand, what we tested in our framework, in our study, sorry. And he also talked about how a broken tool could be used in a state called unready to hand, which we also identified in our model. Also a state of present at hand, where we just look at the tool, we observe the characteristics of the tool. So in our study, we only tested this upper part of the model, so I'm going to concentrate a little bit on that. So in order to be ready at hand, we need to have high skill using an unbroken tool. And then we will get embodied with that tool. And then our attention changes. So we will focus more on the task, and we will focus less on the tool as we use it. So in order to start validating our framework, we constructed a study. We were thinking of what is this repetitive task that we can use and introduce in order to kind of get into being embodied with the tool. So we thought about a wrench. but not quite this range that we built. So this is our virtual tool and our physical tool that we use in our study. So, and participant will be interacting with it on a touch screen with a virtual tool using their thumb and index finger. And we approximated a physical tool that also represents that virtual one in the physical environment. So what the participant have to do with these tools? So the tool have to control an object. So our ball here is an object that they control, and they basically use that tool in order to rotate that bolt. But rotating the bolt is going to be a little bit tedious. What they have to do with that bolt as well is to complete a task. So they have to select and we had two tasks, easy task and hard task. In the easy, they just have to make a selection of one letter. So basically rotating the bolt in order to make the letter A selection, for example. And the selection happens when the letter is facing up. In the hard task, however, they have to form a word. So let's say they have to form idea using those sets of letters that we have on the tool. They still have to make a letter selection, but they have to do it in a sequence to form a specific word with the bolt using the tool. And the measure that we took in our study was how much, as you can see on those tools, there's a lot of LEDs. There's actually 8 LEDs on each of the tools. And we asked participants to report any changes that happens with those LEDs. For example, they might change from darker to brighter or brighter to darker, and then participant will basically report that during the experiment, which I will show you in a moment. So as you can notice here in this video, this is the virtual settings, this is the physical setting using different tools. So they would do, this is actually the easy task. They would do just one rotation and go back to the starting point. You notice that some of the LEDs are a little bit darker, some of them are brighter, and they change. And we basically ask participants to report these changes by pressing the space on the keyboard. We had 32 participants within participant design. We had 2 factors, tool type, virtual versus physical, and difficulty, easy versus hard, that I just showed you. This is our experimental setup. We had 2 monitors. The first monitor was the actual place they were interacting with the tool. So for the physical setup, I would basically bring a prop and put the physical setup on the tool itself, so they will be interacting with it. The second monitor is only for information, so showing them the letters, showing them the word that they need to form. And they would also use a keyboard in order to report any changes. So they would press a keyboard, which pauses the changes, they would report them and continue back. So as I mentioned before, the participant have to do in the task, they have to do 2 things at once. So this can be called a kind of a dual task paradigm. So they basically perform a primary task of rotating and forming a word. And in the same time, if they notice anything that happens in the experiment, on the tool, there's a secondary task of reporting or the measure that we are taking. Before getting into the task, they would have to do 10 minutes of a motor training, which is basically rotating the object using the tool. And then they would do a reporting training, 2 minutes of reporting training before starting the task. So in this video, the only difference between the actual task and the training, and when they start with the training, is that no changes happen on the tool. They just, for 10 minutes, kind of use the tool using their thumb and index finger in order to rotate an object. They are not given any information at the beginning about what to do next, but then they will be trained on that as well. And they do it both in virtual and physical conditions. So this is an example of a physical easy task that they do. So they do both physical easy and physical hard, and virtual easy and virtual hard. In the physical and easy task, you will see the second, on the left side, there is more information which is presented on the second monitor. It's showing them which letter they have to rotate to, and they go back to the starting point. Changes would happen on the tool. Here, I'm not actually reporting any changes, but participant would stop and report changes. So this is an example of a virtual hard task. So in the virtual hard task, we can imagine that they have a word-like idea to form, and as they would rotate the object, when they get to the letter that needed to form that idea, a green circle will appear above that letter saying, yeah, you got that letter, go get the next letter, and go on to form that word. When the word finishes, they will get another word in order to continue with the task. So in our study, we took an attentional shift measure, and we also took a lot of performance measure, but I'm going to talk particularly today about the number of tasks completed. So what is attentional shift? And this is our main measure that ties back to our model. And by attentional shift, I mean there's how many LED changes happen near the hand, which is in green in here, versus what happens near the action. So we kind of divide the tool space into two sections, near the hand section and near the action section. And we were looking to see how much they miss near the hand and how much they miss near the action. So if being embodied with the tool, they have to concentrate, they have to focus on near the action. They should be paying more attention. They should be missing less near the action and missing more near the hand in order to look at our framework. So this is, again, back our framework, and I'm talking about this kind of the upper level of that framework. So in order to be ready at hand, in that ready at hand state, you have to have high skill using an unbroken tool. Then you will be embodied with the tool, and then your attention will be focused on the task. But particularly in our experiment, because we divided the tool space into two sections. So our attention near the action should be more, and our attention near the hand should be less. So basically, taking our measure into account, they should miss more near the hand, which is this section of changes of the LEDs, and they should miss less near the action with both. So this is the result. This is show a summary of our results for our attentional shift measure. So as I mentioned before, there's the near the hand is represented by the blue bars, and near the action is represented by the green bars. And we found out that people are missing more near the hand in both physical and virtual condition, as we predicted, except of the easy physical condition. We didn't find any statistical difference there. We also took performance measure, the number of tasks completed, and we found out that they are doing less tasks in the virtual condition. They are able to perform less tasks in the allotted time for the experiment using just performance measure. So to conclude, we are proposing the use of the concept of readiness to hand as a measure through attentional shift as an objective measure of tool embodiment. We have proposed a framework to measure embodiment in a direct and objective way. We have developed an initial methodology to measure embodiment through attentional shift. And so how can we use the ideas that I presented here? So one of the things that we did is build that framework, which was a philosophical concept and been talked about a lot. And that's, we can take that framework and apply it to any type of technology, provided that there is those three elements. There is a tool, you're trying to control an action with a tool, manipulate an object, and there is a stimulus where you can put that stimulus distributed between the hand, the tool, and the task, where you can compare how much attention you're paying to different elements. We also showed that performance measures were insufficient into measuring tool embodiment. So we also have some limitation. This is the first step. This is only an initial step, and there is a lot of validation and more experiments that are needed using our framework into more studies and different interactive modalities. We also didn't find any significant embodiment difference between the physical and virtual tools. So just to summarize and kind of tie back to our main message, we constructed a framework which can be used to directly measure tool embodiment by comparing attention to the task versus attention to the tool. Thank you.
Ayman, thank you so much. And I guess we have time for one or two questions. Please. Don't be shy. Okay, Ayman, I have one. So you looked at a very specific task now, right? Where you looked at one virtual and one physical representation, and you didn't really find significant differences. Could you speculate about tasks or tools where you would hypothesize or where you would expect differences in handling virtual versus physical tools?
So This is a really good question, and this is one of the things that we are thinking doing in the future. Is that maybe with a different interactive modality, like maybe virtual reality, holding versus not holding an actual physical tool in your hand would make a difference. Would make a larger difference that could be detected. So this is something that we're thinking about in the future.
Okay. Great.